Ladies and gentlemen, welcome back to another riveting episode of Flip Your Algebra Classroom. We are finishing up with section 9.1 today, which is properties of radicals. Okay? And honestly, you guys, this stuff today is going to go fairly quickly. So I'm just going to jump right into it. This first example that we're looking at, the ratio of the length, so of length to width, of a golden rectangle is 1 plus root 5 all over 2. So now they give you a picture of the Parthenon in Greece. All of these sides create just a golden rectangle, which basically means that it's very, very pleasing to the eye. Like the dimensions are very easy to look at. What they want you to do, so you're missing the height here. They want you to go ahead and figure out, okay, what is the height of this building going to be? So first thing that we want to do, remember, it's length to width. Okay, so the length is going to be 31. We're going to put that on top here. And the width or height is going to go on our bottom. So we just created a proportion. And now what we know that we can do with proportions is we can just quickly do a little bit of cross multiplication. So that would be h times 1 plus the root of 5 equals 62. And then our job or our goal is to, because we're in algebra, our goal is to isolate h, get h all by itself. And why are you doing this to me? Sorry, guys. So we want to just isolate h. So what we're going to do is we're going to just get it all by itself. So we're going to take that 1 plus root 5 and get it over to the other side. Okay, so now that leaves us with h equals 62 divided by 1 plus root 5. Okay, and the thought and the theory behind this problem, you guys, I understand is like, you guys should be able to just, okay, well, let's just take this, plug it in the calculator, and we'll come up with whatever. But remember, we're trying to just get really good at our skills in terms of like other problems. So remember, whenever you have a root in the denominator, you want to make sure that you get rid of that root. And since you have a positive expression, you want to take the conjugate, you want to multiply both numerator and denominator by that conjugate. Okay? So then this numerator is going to turn into 62 minus 62 root 5. And then your denominator is going to turn into, okay, so firsts are going to be 1. Insides, outsides, those are going to end up canceling each other out. And then lasts will be 5. Okay, so now let's take this right here and let's simplify. So you've got 62 minus 62 root 5 all over negative 4. And when we're thinking in terms of height, ladies and gentlemen, do we ever talk about height as like, oh, yeah, I think that height's probably about 62 minus 62 root 5 all over negative 4. I mean, let's think about that for a second. No, we don't talk about height that way. Okay, so this is an instance where, yes, now that we've got this simplified, now that we've practiced our skill of using the conjugate and putting that conjugate into play, we are just going to take the calculator now and simplify this. So if we do 62 minus 62 root 5 in the calculator, that'll end up giving us negative 76 point, and then it's a long decimal after that, 6, I'll just approximate it as 6.4, divided by negative 4, which is awesome because you want that height to be positive. So you've got a negative over a negative. Let's just take that divided by negative 4. The height of this, of the Parthenon is going to be 19.16 approximately. And then the label on that is going to be meters. Okay, then we're going to take a look at just these next 4 examples on the next page, and then we're going to be done. So actually, this material goes rather quickly. So you guys, the next set of problems that we're working on are just, again, they're simplification. But what we're going to try and do, well, not try and do, what we're going to do is we are going to look at the process of combining like radicals. Okay, so we defined like radicals early, like in video 1, basically just as radicals that have the same number underneath the radical symbol. Okay, so we're just going ahead and we are adding like radicals. So search for the radicals that have the same, right? This is the same, this is the same. There is no other root 11. So we're just going to go ahead and we're going to say, okay, I've got negative 8 root 7 and I've got positive 5 root 7. That's going to give me negative 3 root 7. And then, I mean, that root of 11 is just going to stay the same. And that's honestly all there is to it. So problems like letter A, it's just a matter of finding the same radical. But now when it comes to letter B, okay, this time we do not have any noticeable like radicals, okay? But you have to start getting really good at recognizing, hey, this 20 here, there's a perfect square inside of there, right? If I, again, start listing all of those perfect square numbers, we've got 1, 4, 9, 16, 25, yada, yada, yada. I don't think I need to go any further here. But there's a perfect square inside of there. Right? There's a 4. So what we need to do first is we need to break this down into root 4, and then looky what happens. That turns into root 5. Okay? So we have 10 root 5. That just comes from this piece right here. And then this root 20 turns into 2 root 5. Okay? So these type of problems are coming your way. You have to be able to identify when you need to simplify and when you don't. And this is an instance where you do. So then go ahead, combine those like radicals, and that gives you 12 root 5. And then lastly, we are looking at, again, super, super simple. You got cube root of x, add these first 2 numbers together. 8, cube root x, boom, done. Washed your hands of it. Okay? Really, really very simple. But if you have any questions or concerns, let me know. We're going to move on to the last example, which is simplifying using the distributive property. Okay? So we know that anytime there's a number out front here, we have to distribute it through. So first step is going to be to do that, and you just multiply the numbers that are underneath the radical symbol together. So that would be the square root of 15, and then minus, so then we have to take 5 times 75, so grab your calculators, do that calculation quick. 5 times 75 will give you the root of 375. Okay, I guarantee you guys there is a perfect square inside of here, because I know it's not a perfect square on its own, but there's got to be one inside of there. 1, 4, 9, 16, 25. I bet this is the one. Okay? So if we take 375 divided by 25, interesting. It's like the book tries to do stuff like this. So then you take the square root of 25, and then look at what the other root turns into. So we've got 5 root 15, and then the root of 15. Okay, so then when they're simplified, like, remember, there's an imaginary 1 out front there. That turns into negative 4 root 15. Okay, your task now is to go ahead and do 23 through 28. But we have officially finished up with section 9.1. So make sure that you get those last 4 questions done, or excuse me, there's 6 of them. Get those last 6 done, and then if you have any questions, comments, or concerns, make sure you write them down on the side, and I will talk about them tomorrow. Have a great rest of your night. We'll see you tomorrow.